Here's the example. Find the centroid of a triangle with these vertices right here. So let's try to draw it. Let's see. 1, 10, 5, 0, 9, 5. So everything's in the first quadrant, isn't it? So I'll be a little more careful with how I draw my x and y axis. Alright, so there's a nice little x and y axis. Let's put some points on here. 1, 10. So help me count. 1, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that it? Did I skip one? Sometimes I skip one. I don't know why. Alright, that's 1, 10. And I'll even put that on there. 1, 10. Then 5, 0. 1, 2, 3, 4, 5. That's 5, 0. And then 9, 5. That's 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. Okay, so that's 9, 5. It says find the centroid of this triangle. Well, I got to make it a triangle first of all, don't I? So we go to here, and go to here. All right, finding the centroid. Well, we just talked about finding the centroid, didn't we? That was yesterday. So what do we have to do to this triangle, or to the angles or the sides or whatever? What do we have to do to find the centroid? Find the medians. Very good. Okay, so we find the median, which means what? We go from here, and am I doing the right one? Yeah, I am doing the right one. Yeah, so we go from a vertex to the midpoint of the opposite side. Okay, from the vertex to the midpoint of the opposite side, vertex to midpoint of the opposite side. I'll tell you what, you could start from any of these vertices. It doesn't make any difference. All right, what I'm going to do is this. Hold on just a second. Okay, I had to look at the example that I had written down to make sure we do this right. You could go from this vertex to the midpoint here, vertex to the midpoint here, or vertex to the midpoint here. I think the easiest one, just looking at this particular triangle, okay, this only works for this particular triangle, I guess, but I'm going to go from this vertex to the midpoint of the opposite side. All right, so I want to go, now where is the midpoint? Is it here? Is it here? Do we just eyeball it? No, we probably shouldn't. Even with graph paper, we probably shouldn't just eyeball it. Now, it looks like it's probably right there, doesn't it?
Yeah.
Okay, and we might get lucky with that. But what if we did this? What if I started here and I wanted to go from here to the midpoint of the opposite side? You know, is that here, here, here? It doesn't look like it's really going to hit right at one of those little grid marks, does it? All right, so I want to not just go by the graph. I want to go by the numbers. All right, because sometimes it's, your graph doesn't look as nice as this. Sometimes you don't use graph paper. Sometimes you just sketch it out on paper. So we want to go by the numbers. So I want to find the midpoint. Now you could do this. You could go from here to the midpoint here, but it might not be quite as easy or pretty to do that. So I'm going to go from this one to the midpoint to the other side. So what do we have to find then? We got to find the what? The midpoint of this side. So let's do that. Remember how to find the midpoint? Let's go to this. All right, so the midpoint is equal to, now it's not changing x, that would be the slope. Okay, remember this? Right. Add up the x's and divide by 2. So I'm trying to find the midpoint of this segment right here, from here to here. So we add up the x's. We can just do this in our head, can't we? 1 plus 5 is 6. Agreed? And then add up the y's. 10 plus 0 is 10. So what's my ordered pair then? 3, 5. All right, that's without a doubt. Okay, I'm not just guessing. I'm not just relying on my, on my graph, on my accuracy on my graph. I know exactly that's the midpoint. Would you agree with that? Okay, so let's come over to 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. Yep, it's right where I thought it was. But like I already said, right here, if I just guessed where the midpoint was, that probably wouldn't be the best thing to do. So I just wanted to go through this so that you could look and you could know how to find the midpoint. Travis?
Can you find the midpoint of any side, or you just find
Sure. I can find the midpoint of any of these sides. In fact, I could find all three, but I'm not going to have. I don't really have to, and I'll show you why in a second. All right. So what I'm going to do is connect the vertex to this midpoint. So what did I just draw right there? I just drew the what? What's the word? The median, right? I just drew the median from here to here. Now watch. The centroid. Now I could draw all three medians, couldn't I? All right, and then they should intersect at one common point, which would be the centroid. But I actually don't have to do that on this because I know where the P is going to be. Where is the P going to be? It's going to be 2/3, the P meaning the centroid. Does that make sense? Because we used P yesterday to represent the centroid. Where's the centroid? It's from here. It's 2/3 of this whole thing, isn't it? All right. Or it's what? 1/3 from here to here. Let's do this. Now, since this goes horizontal, this is kind of easy for us to find the distance from here to here. Do you agree? What is that point? That's 3, 5, isn't it? Okay. So if I wanted, I could just count. So I'm at 3. I'm going to 9. So what's the length of this whole thing? It's 6, right? I'm starting at 3, going to 9. The whole length is 6. Agreed? The short part is how much of the whole thing? It's 2, right? So, right, it's 1/3 of this. So 6 divided by 3 is 2. So watch what I do. I go over 2 places. 1, 2. Guess what that point right there is? That's the centroid. Do you see that? I don't have to actually draw the other 3 because I know if I draw one of these medians, I know that the centroid is 1/3 of the distance from this side to wherever the centroid should be. So I find the whole length. The whole length is 6. What's 1/3 of 6? Well, it's 2. 2 from where, though? 2 from here, right? So I count over 2. 1, 2. Boom. That's the centroid right there. And what do they ask for? They just ask you to find the centroid. So what is that ordered pair? 5, 1, 2, 3, 4, 5. So that point right there is 5, 5. Does that make sense? All right. Now, again, you could have drawn all 3 medians, and if you did it accurately, they should all intersect right here at 5, 5. Okay? But I looked at it and I said, you know what? I can get away without drawing all 3 medians. I can just draw one of them and then find the length of it, take 1/3 of it, and then from here to here is that length, and that's got to be where my centroid is. Okay? All right. So it makes it a little bit easier. All right, let's do another one with the orthocenter. This one's a little bit more complicated. All right, so I would write this stuff down if I were you. A lot of people not writing anything. I probably would write this one down. All right, here's another one, but this time we're going to find the orthocenter. Now, to find the orthocenter, we have to find the altitude, which goes from the vertex to the perpendicular to the opposite side. But first of all, let's plot this thing out. And I didn't make that last triangle. I just made the triangle black and I made that medians red, didn't I? Is that what I did? Okay. So let's see. -2, 4. -2, 4. 1, 2, 3, 4. All right. That's point F. And then 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. Right there. And then 1, -2 would be right there. All right. Let's connect these. Right there. Right there. And then right there. All right. So far, so good, right? Let's put those points in here, though, just so we can see them. That's -2, 4. That's 4, 4. And this is 1, -2. And we want to find the orthocenter. Now, the orthocenter starts at a vertex, and it goes perpendicular to the opposite side. It's not quite as easy just finding the midpoint over here, is it? So we have to make sure. We're not just going to eyeball it. I want to make sure. I want to know the exact numbers. To take a line and make it perpendicular to the opposite side. Well, what do we know about lines that are perpendicular to each other? We know they form a right angle. I understand that. But as far as something else that we talked about as far as lines being perpendicular, right, the slopes, right? The slopes are the negative reciprocals of each other. So what I want to do is I know I'm going to start here, and I want to draw a line, and I want to know the slope of that line. I could sit there and just look at it and just kind of guess what's perpendicular. But do you think that's the best way to do this, to get an accurate answer? No, it's not. So what I want to do is I want to find exactly the line, the slope of this line that's perpendicular to this line. So what does that mean we're going to do? Oops, let's make this smaller. Okay. What are we going to do then? We're going to find the slope of this line right here. So let's find it. So the slope of this line. Now, do you remember how to find the slope? That's what you said before, Jasmine. What is it? It's the change in y over the change in x. So it's going to be 4 minus -2, which will be 4 plus 2, over 4 minus 1. That's what? 6 over 3, which is 2. So the slope of this line right here is 2. So what's the slope of the line that's going to be perpendicular to it? -1/2. Negative reciprocal. Okay, so you take the opposite sign and you flip this number right here. So the slope of this line is 2. If you wanted to, you could have just counted, couldn't you? Rise 2, run 1. right? But sometimes if you're not real accurate, if you're just doing it on a blank sheet of paper, you know, and sometimes you can't always just count up and over. So I'm doing all the math, right, to make sure that we know. So what I'm going to do, I'm going to go, I'm going to start here. I'm going to have a slope of -1/2. So it means I go down 1 and over 2. You see that? Down 1 over 2, down 1 over 2. So it's going to connect from here to here. All right, I'm just going to, it's about right there. Does that look about right? Yeah. Okay. All right, so there's the slope of that line right there. Now, in order to find the orthocenter, though, I've got to find the intersection of all three of those. But if two of them intersect, don't you think the third one's going to intersect in that same point? Do I really need to bother doing all three of them? No, if I just show where two of them intersect, you know the other one's going to intersect in that same point. All we're looking for is that point where the three intersect, okay? So if two intersect there, that's all I got to do. So let's do this. This might be an easy one since this is vertical right here. Look, this is horizontal, isn't it? -2, 4, and 4, 4. And if I want to draw from this vertex perpendicular to this side, basically just what kind of line do I have to draw? Vertical, vertical. Horizontal will go this way. Okay, I don't draw horizontal, I draw vertical. So it just goes straight up like this, wouldn't it? Follow me? All right, so where's the orthocenter? It's right here. Can I just look at the graph and just guess where it is? I mean, I might be able to. And in fact, if you guessed where it is, I bet you would be right on this. But you can't be guaranteed. Right? What would you guess that point is? Well, it's 1. We absolutely know it's 1. It looks about 2.5. But how do you know it's 2.5? How do you know it's not 2.4 or 2.6? You with me on that? Okay, we're not positive. We're pretty sure it's going to be very, very close to that. And in fact, when we do the answer, it is actually 2.5. But we can't just rely on that. Right? If you don't graph it out nice and perfect and we had nice straight lines and all that kind of stuff, if you just kind of sketch it out on a piece of paper, you may not know that that's exactly 2.5. It's not a reliable source. So what we have to do is find that point of intersection. We've done this before. We've actually found the point of intersection of two lines. So how do you find this point that both of those lines intersect each other at that point? How do you find that point? Do you remember what we do? I guess not. What we're going to do is we're going to find the equation of both of these lines, and then we're going to do some algebra, right? Some substitution or elimination, and then solve for x and y. So let's find the equation of these lines right here. Let's do the up and down one first. That's the easiest one. Okay. So this one, this vertical line. It's a vertical line. So what's the equation of any vertical line? It's always what? It's always x equals wherever it crosses the x-axis. Where does this vertical line cross the x-axis? At 1. So that's one equation right there. I'll put it in a little box, hang on to it for safekeeping. We'll come back to it. That's the equation of that line right there. Okay? Now what I got to do is find the equation of this line right here. Well, that shouldn't be too hard because look, I already know a point that it goes through, and I just found something else. What did I find in order to even draw that thing? I found the slope of that line, didn't I? All right, so let's figure it out. I've got a point, which is -2, 4. Again, you could probably just look at this, but again, I want to go by the numbers, not just by what the graph looks like. I mean, I'll be honest, I was pretty accurate on this graph right here, but I don't want to just go by my level of accuracy because not everybody's going to be as accurate. So that point's -2, 4. What's the slope of that line? This one right here. No, it's not 2. This one's 2. This one's rise 1, run 2. Right? So it's rise -1. So what's the slope? -1/2. Right? We talked about that from over here because this slope was 2. This is the negative reciprocal, and there you go. So watch what we have now. Let's find the equation of that line. So it's 4 equals, because it's y equals mx plus b, right? Y equals mx plus b, so y equals m, which is -1/2, times x, which is -2, plus b. Let's do this quickly. That's 4 plus b. So what did I do? Oh, wait a minute. Not 4. What's that? That's 1, isn't it? That's 1. Subtract a 1, what's b? It's 3. Just like we thought it would be, right? So what's my equation of that line? Y equals -1/2 x, what? Plus 3. All right, there's my work right there. I'm running out of time, and that's the orthocenter. That's the x and the y, and that's all you have to find. That's it.